All right, next up, we're going to talk about the actual mechanism of breathing. So, ventilation or breathing has two phases: inspiration, which is the inhalation, that's moving air into the lungs, and expiration or exhalation, it's moving the air out of the lungs. So, to understand ventilation, it's necessary to remember the following facts. Normally, there is a continuous volume of air from the pharynx to the alveoli of the lungs, but ventilation is governed by Boyle's law. So at constant temperature, the pressure of any given quantity of gas is inversely proportional to its volume. We're not really going to spend a lot of time with Boyle's law. This is something that you'll see a lot if you take a chemistry course, but what I just really want you to understand is the process of air pressure. So what happens is this is our normal volume of air. When we expand that volume, air pressure is going to decrease and air is going to move in. In the event that we squeeze on those sides, air pressure is going to increase and air will be pushed out. So you can kind of think of it like, I don't know, what's a good example of a balloon? If there was a picture of a balloon with a very small hole in it, if you were to push on the sides of that balloon, air is going to escape. If you were to actually be able to stretch out that balloon in all directions, air is going to rush in. And so the interesting thing is that the lungs lie within a sealed thoracic cavity. There's the rib cage, which is the top and the sides of the cavity, and then the intercostal muscles between the ribs, and then the diaphragm forms the floor of the cavity. The lungs are going to stick to the thoracic wall by way of the pleura. Remember, I mentioned that the pleura is covered in that mucus, and surface tension is what forces the lungs to stick to the thoracic cavity. And so that space between the two pleura is minimal. It's filled with that pleural fluid. So what happens is here we have our lungs. They're going to stick to the walls of your thoracic cavity. And what happens is during inspiration, this is the active phase of ventilation, the diaphragm and the external intercostal muscles are going to contract. So the diaphragm is sort of this U-shaped muscle. And when it contracts, it flattens downward. So it's going to push down. And so like I said, in its relaxed state, the diaphragm is dome-shaped. During inspiration, it contracts and it flattens downward. Contraction of the intercostal muscles causes the rib cage to move upward and outward. When we do this, we're going to increase the volume of the lungs, or we're going to increase the volume of the thoracic cavity. When we increase the volume of the thoracic cavity, it's like pulling that balloon outward. When we pull that balloon outward, air is going to rush in and fill those lungs. So both of those actions increase the size of the thoracic cage. As the thoracic volume increases, the lungs are going to increase in volume as well, because the lungs adhere to the sides, the walls of that thoracic cavity. As the lung volume increases, the air pressure of the alveoli decreases. When that alveoli air pressure is less than the atmospheric air pressure, air is going to flow in. Okay? So, inspiration, to sum it all up, contraction of the muscles makes the thoracic cavity larger, and air is going to rush into the lungs. Expiration is the exact opposite. So this is going to be the passive phase of breathing. And the reason that it's passive is because in its relaxed state, the diaphragm is going to be domed and the intercostal muscles are going to be pushed inward and downward. So this is the passive phase. This is it when the muscles are in their relaxed state. The diaphragm and the intercostal muscles relax. The rib cage returns to its resting position, moving down and in and down. There we go. And the lungs are going to recoil. The air pressure inside the lungs increase and air is going to flow out. So it's like squeezing that balloon, squeezing that balloon in, and air is going to release or escape. So as the lungs recoil, the pressure between the pleura decreases. It keeps the alveoli open. So in the event that you have an accident and the thoracic cavity is punctured, so if you've ever heard the phrase of a punctured lung, the air is going to enter the space between the two pleura. This is actually going to cause the lung itself to collapse. It won't be able to fill up with air. It won't be able to inspire and expire as needed. Okay, so so for this section, explain how the volume of the thoracic cavity affects the pressure in the lungs. I really just want you to know the relationship between volume and pressure. So as the volume increases, the air pressure decreases and air rushes in. As the volume decreases, the air pressure increases and air pushes outward. This would be a really awesome opportunity for you to send me some extra credit videos on inspiration, expiration, lung volume, air pressure. All of that would be an excellent opportunity for you to send me some extra credit videos. And I'd be happy to go over any of this in our discussion time as well.